My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 379. In this lecture, we will try to understand domain specific kernels. Till now, we have seen polynomial kernels and RBF kernel, and we showed how RBF kernel is equal to the KNN, and hence it is very nice general purpose kernel and very good for most tasks. We saw that kernel trick or kernelization is similar to feature transformation. There are a lot of domain specific feature transformations. Feature transformation is an art part. There are lot of domain specific kernels in machine learning. We will try to understand few domain specific kernels. What people have done as SVM become more and more popular in 1990s and early 2000, people have come up with lot of specialized kernels for specific tasks. The most important in whole of machine learning is feature transformation. Since feature transformation is equivalent to kernelization, people have come up with specialized kernels. If you Google search for string kernels, you will get a bunch of articles. I am typing just string kernels in Google search. What we are getting? Text classifications using string kernels, isn't it? 11 kernels for structured data. You can see a lot of articles. Just see, for example, here you have so many articles, isn't it? This one is something string kernels for native language identification, in string kernels for protein sequence comparison. You can see bunch of articles, text classification using string kernels. Similarly, you can see other articles. Let me type genome kernels. The people from bioinformatics, just they may search for genome kernels. Just see kernel based whole genome prediction, kernel methods for large scale genomic data. You can see lot of articles, papers. The people who are working in bioinformatics are using this stuff. Just see Gaussian G kernel for estimating genetic values. There are so many domain specific kernels, even you can see. So what people have done over the years, they have spent lot of energy and time in designing domain specific kernels. If I say graph kernels, you know what is graph? Graph means what? Basically G is V comma E, set of vertices and ordered pair set of vertices and edges. These are the vertices. You can have edges. You may have directed graph, and you need not just browse. You know how to what is graph. Basically, here I need not define what is graph. Just understand that there is kernels like graph. Graph kernels is a kernel function that computes an inner product on graphs, isn't it? There are so many domain specific kernels. These what people have done over the years, they have spent lot of energy and time in designing domain specific kernels. If you are solving the problem, of course, RBF is again a general purpose kernel. If you don't know, if you don't have domain specific kernel, it's preferable to use RBF. That's what we discussed, isn't it? Given the problem that you want to solve, for example, Amazon text classification. For the problem, what is Amazon text classification? For the problem, of course, you can use RBF, but it might be better to use string kernels, because string kernel designed for text classification. Similarly, if you are solving problem related to genome data, of course you can use RBF, but it is better to use special genome kernels, which people in the domain area have spent lot of energy and time in designing these kernels. So effectively, we can say feature transformation and domain knowledge creates custom kernels or domain specific kernels. for domain specific kernels for relevant problems. Given a real world problem, it is always important to research for right kernels for that problem. Of course, as I told you, you can always use RBF, but it is better if you can find context specific kernel. So feature transformation, which is the hard part of machine learning, is partially replaced. It is not fully replaced by finding the right kernel. In feature transformation, earlier what we have to see, whether log x works, whether x square works, whether e power x works, all these are function transformations that we are trying to see which of them works better. In a case of SVM, we are trying to find a right kernel, but in feature transformation, we are trying to find right transformation like x, log x, x square, e power x. Always when you solve real world problem, please search for relevant kernel or existing kernel in the literature. Which suits your problem, use those kernels. If you don't have any kernel, always RBF, that is radial basis function kernel, is your backup plan. Just go through this lecture. If you have any difficulty, just keep a comment. Thank you very much.